Okay, the next two lessons, today quadratics and tomorrow higher order polynomials, are both going to involve technology. When you do your tests in this unit, you're going to have an iPad or something available to you to use technology. That way you can solve some of the problems that involve it. In today's world, there's technology all around us, right? And we have to be comfortable using it and how to find it and what it can do for us rather than having to do everything by hand. If you have a phone, an iPad, a computer, whatever you have in front of you, eventually we're going to be going to the website www.desmos.com on the first page there of your lesson. I'm gonna show on the computer here, and we'll work through some things together just to show you how it works and the kinds of problems we can solve with it. We're going to start with quadratics today because that's something we're kind of familiar with. We spent all grade 10, grade 11 looking at them and how we can actually determine some things about these models that we've created. Generally with quadratics, there's three important things you want to look at. Okay, you want to know your zeros. Okay, those are often really helpful. Where something hits the ground, where things break even, all kinds of different applications for zeros. As important, if not more important, the vertex, where your parabola changes directions, the maximum or the minimum, the highest, the lowest. There's all different kinds of things you can use that for. And the third one is the y-intercept, the starting point. And we've been talking about these in terms of polynomials, but we're just going to go back to quadratics just so we can get comfortable with the technology, not just the ideas that we're going to be looking at. Okay, so if you could, open up this Desmos thing here. I'm going to open one on my screen so you guys can see it. This link to the website. It's a free website. You can get it on your phone. You can download an app if you want to. It's a really handy one for graphing things and calculating things. Okay, so I'm going to sort of go back and forth between the two screens. Just some examples we can look at. So we got a soccer ball. Okay, its path is given by this equation where x is the time since the ball is kicked and y is the height of the ball above the ground in meters. So I want to put this into my graphing calculator here. Sorry, I'll open this one. Okay, and the way I'm going to do this, I'm going to enter all the information that they're giving us into this equation here on the left-hand side. Okay? At the bottom, you get sort of a keyboard, and we're just going to use the keyboard to type things in. We don't have to use our own keyboards. We can use the on-screen one. Okay, so we're going to make it look just the way it looks. So y equals a negative. You have to put a minus sign in. So -4. There's an x. We want to square it. You might notice our graph starts doing things as we're typing it in. And every time you type something extra in, it does something more. Okay, plus 10x. And logically thinking, that looks like the path of the soccer ball, right? It starts, goes up, comes back down, hits the ground again. And yes, there's more to the parabola, but in our practical sense of the matter, that part at the bottom there, that would be like this part down here, it's not really meaningful to us, right? Our path, that would make sense. Okay, so I want to answer some questions about this based on that equation. Find the zeros and vertex and explain what the coordinates tell you in terms of the problem. So if I go to that graphing calculator, the nice thing with this one is, I don't know if you noticed, but there's some gray spots that show up. When I touch them, I'll get rid of this ink here for a second. Delete that part, and we'll delete this part. If I touch these little gray spots here, they tell me the coordinates. So here's a 0, over here is another one, and up here is my vertex. And that's the things I want to write down. Okay, so on my screen, I'm going to go back here and say, okay, my zeros were 0, 0, and the other one was, I think it was 2.5, right? Yep, 2.5 and 0. And what are those? Well, that's where it starts. So it starts on the ground, and it lands, and by it, I mean the soccer ball, lands 2.5 seconds later. Okay. Our vertex, we touched that one, we got 1.25 and 6.25. So vertex, 1.25 and 6.25. What does that mean? Well, remember this is your time right here, right? This is your height. So after 1.25 seconds, it reaches a max of 6.25 meters. And I can do that without having to draw it out by hand, without having to do any calculation, any algebra. I like the technology, it does a lot for me. Hey, does the ball reach a height of 6 meters? Well, looking back, we just wrote down the vertex, 6.25. Yeah, for sure, yes. It reaches all the way up to 6.25 meters, right? it reaches 6.25 meters. So definitely hits 6. How long is it above 2 for? Well, we know it hits 2. How long is it above 2 for? So to do this, we're going to add them into our graph. So let's go back to our graph screen for a second. 2. Well, look at my graph. 2 would be sort of like a line that goes along here, right? 1, 2, so, but I want to know the exact spots. To do that, I'm going to draw a line with the calculator at that line. And here's how I'm going to do that. I can go down to line number 2. I'm going to make an equation that says y equals 2. And it's going to draw a nice horizontal line in for me, which is exactly what I want. There's 2 meters. So my question was, how long is it above 2? And if you notice, there's 2 spots, one right here, there, another one over here, where I pass 2 meters, one on the way up and one on the way down. I'm going to write down both of those. So 0.219 on the way up, so up 0.219, and down, the down one was 2.281, which makes sense, right? It should be going up and going back down, passes 2 meters twice. The question was, how long was it above 4? So it was above 4, the difference between those two things. So above 4, and if I take 2.281 and I subtract 0.219, I end up with 2.62 seconds. Oh, sorry, 2.062 seconds. Just a 0 in there. Okay? Yeah, we solved some things with technology. Pretty quick and easy, right? Okay, let's try the next one. Alex, tossing pine cones from the side of an old quarry. The pine cones fall into the water-filled hole below, and the height of the cone above the surface of the water is given by this equation. X is our time in seconds, since he tossed the pine cones. So let's go graph. Let's get an idea of our shape here. I'm going to move it down so I can see the equation. I'm going to get rid of these by touching the x's. Gets rid of my equations. I want to make a new one. So I can type in y equals negative 5x squared plus 15x plus 20. And if I look at my thing, it's actually going off the screen a little bit. So on the right-hand side here, these plus and minus buttons, these ones right here, allow me to zoom in and out. So I want to zoom out a little bit so I can see things. I'll zoom out a little bit more so I can see things. Okay, I can move the things around if I want to. Okay, I need to see the important parts of this. I'm being asked to find the zeros, the vertex, and the y-intercept. All things on the graph that have gray dots. Okay, the zeros, there's 1, 2. The y-intercept is up there, and the vertex is up there. Those are the 4 things I want to write down. Okay, so my zeros, negative 1, 0, and I think it was 4, 0, right? Yeah, 4, 0. The vertex, and from there we got a vertex of 1.5 and 31.25. And the y-intercept was 0 and 20. Okay, there's my points. What do they mean? Well, it takes 4 seconds to hit the surface. Yeah, that's time, right? Until if you look at the picture, the path of this is the path of my pine cone. So he's here, pine going up, and then back down hits the water. Right? That's what's happening here. Okay, the vertex. After 1.5 seconds, the pine cone reaches a max of 31.25 meters. And what's my y-intercept? That's my starting point. Okay, Alex is 20 meters above the water. He's on like a cliff or something. The side of the quarry, right? That's my starting point. Hey, but I can find those things really quick with this technology stuff. Hey, part B, why do you think the leftmost x-intercept is not considered important? Notice I didn't write anything down about that one, right? Because my leftmost intercept, that would be this one, doesn't make any practical sense. I can't have negative time. So that's really my reason, right? You can't have negative time. Yes, it can be used to make our equation, but it doesn't make sense in a practical sense whatsoever. Okay, so I don't use that one to explain anything. It's like going back in time or something like that. How long did it take for the cone to fall below a height of 10? Yeah, so my picture, I need to find where is 10. Now, I could probably guesstimate it's about 10, right about there, but I want to know the exact value, right? So to do that, I'm going to put in an equation. I want to know where is 10. So y equals 10. There it is. And I want to know where they are, so I'm going to touch that right there. 3.562. So that takes 3.562 seconds to fall to 10 meters. This time I don't have to do any subtracting or anything like that, because remember, we started at 20. So it went up, went back down, but because it was already above 10 to start, I only need one value. Okay, letter D. I'm pulling from the side over here. What is the height of the cone after 3.2 seconds? Now, I can do this the old-fashioned way. I got a function. I can figure out, okay, f at 3.2, because this is my x value, right? I could do that. There's nothing wrong with doing that. If you like using your calculator, go for it. Put it in your calculator. Here's your equation up here at the top. Okay, we could do all that fun stuff. Negative 5 times 3.2 squared plus 15 times 3.2 plus 10. That would work. There's nothing wrong with that. But since we have this technology, oh, sorry, it's plus 20 at the end. Why not use this technology? Here's how we can do that. If I want to know when I hit, sorry, after 3.2 seconds, that would be my x value, right? If I go down to the next line and type in, okay, let's see what happens when x hits 3.2, it's going to make a nice vertical line for me. Okay, if I want to zoom in a little bit to figure out what's happening there, let's see where it crosses. I'll touch it. There's my dot right there. The gray spots are the important ones. At 3.2 seconds, the height is 16.8. Done. Okay. There's some technology. You guys try the next two. I'll put the next video on with the next two so you can see it. But see what you can do yourself just using that technology.